Welcome to MarkLogic University's tutorial, Values, Tuples, and Aggregation in JSearch. This video is a continuation of the JSearch series of topics. Please refer to the Introduction to JSearch tutorial for more information about JSearch. You will learn about the data aggregation functions available in JSearch. The target audience is developers using MarkLogic's server-side JavaScript. A fundamental familiarity with MarkLogic is assumed, as well as completion of the Introduction to JSearch video. The topics we will cover include the dot values and dot tuples top-level methods in JSearch, the dot aggregate method in JSearch, the aggregation functions available, design patterns for returning aggregate values. Code examples can be found at MarkLogic University's GitHub repository at github.com/marklogicuniversity/jsearch. If you go to the site, you can get the examples and follow along with the tutorial. Values are returned using JSearch by using the dot values top-level method. To return values, pass the JSON property name or index or lexicon reference in with the dot value method. If an array of multiple references or JSON property names is given, the results will be a union of the returned values. For more information about index and lexicon references, please see the Search Developer's Guide on docs.marklogic.com. The JSON properties must have appropriate range indexes. In this example, all of the values for the JSON property of title are returned. In the first line, the JSearch library is included. Next, we use the dot values top-level method specifying the JSON property named title. The third line sorts the results in frequency order instead of the default relevance order. .result executes the query and returns the results. Running the search returns the results. The values for the title JSON property are returned in an array. In this example, all of the values for the JSON property of title where the author is Mark Twain are returned. In the first line, the JSearch library is included. The next line uses the dot values top-level method specifying the JSON property named title. The third line specifies a query by example constraint, limiting the values returned to only documents where the author is Mark Twain. The dot result method executes the query and returns the results. Running the search returns the results in an array. This example demonstrates a complete JSearch pattern for returning values, including filtering and sorting the values returned. The first line includes the JSearch library. It's best practice to search over the smallest document set. To speed up our results, we're searching the documents that only belong to a classics collection. Next, the dot values top-level method is specified, passing in the JSON property of title. The dot match method is used if you want to filter the return results to those that match a wildcarded pattern. In this example, only titles that contain the substring of vent will be returned. Optionally, sort the return values. We are sorting the values by the frequency that each value appears in the search. Values can be sorted by frequency or item value. Sorting can be ascending or descending. If you wish to return only a subset of the results, use the dot slice method specifying the starting position and the last position plus 1. We're returning the first 3 results. Dot result executes the query and returns the results. Use the JSearch top-level method of .tuples to return values that co-occur in the same document or fragment. Tuples are returned from indexes and lexicons, so appropriate range indexes must be defined. To use the .tuples method, you can pass multiple JSON property names or use index or lexicon references. References are tags for referring to JSON properties as other names. An example is referring to an indexed JSON property of discount percentage by the tag discount. In this example, values from the author and format JSON properties that occur in the same document are returned. In the first line, we include the JSearch library. Next, use the .tuples top-level method, passing in an array of JSON property names of author and format to find their co-occurrences in the matching documents. Finally, execute the query and return the results. Running the search returns the results. This example finds all of the values for book authors and formats that co-occur in the same document or fragment. The results are sorted by their values in descending order of author name first, then book format. In the first line, we include the JSearch library. We search only the documents that belong to the Classics collection. Next, use the .tuples top-level method and pass in the JSON property names of author and format. The results are sorted by their item values in descending order. .result executes the query and returns the results in an array. Values and tuples can be aggregated using the .aggregate method. Apply an aggregate computation to results of values or tuple queries using built-in functions or user-defined aggregate functions. Multiple computations can be accomplished over the results by passing in an array of desired function names. The built-in functions include computing the sum of values, averaging values, counts, minimums, and maximums. Statistical functions include calculating standard deviation or variance of values, and correlation or covariance of tuples. In this example, we're computing the minimum, maximum, and average prices of all books in our book database. In the first line, we include the JSearch library. Next, we select a resource by choosing the top-level JSearch methods of .values or .tuples. In this example, we want the values from the price JSON property. Add the .aggregate method to specify one or more built-in or user-defined aggregate functions. Multiple functions can be specified by passing in the names of the functions in an array. Compute the minimum, maximum, and average of the book prices. Finally, execute the query and return the results. Running the search returns the results. Constraints can be used to reduce the number of items passed to the aggregate functions. In this example, we are finding the sum and standard deviation of book prices, but only those books where the author is Mark Twain. In the first line, we include the JSearch library. JSearch's by example method can be aliased to better describe that we are doing a query by example search. Select a resource by choosing the top-level JSearch methods of .values or .tuples. In this example, we want the values from the price JSON property. Add any desired where clause using the .where method. We are using the query by example to constrain to books where the author is Mark Twain. Add the .aggregate method to specify one or more built-in or user-defined aggregate functions. The code computes the sum and standard deviation of the book prices for books authored by Mark Twain. The .result executes the query and returns the results. Running the code returns the results. You can utilize functions written in C++ to perform custom aggregation in JSearch. The User-Defined Function API takes advantage of MarkLogic's MapReduce capabilities for computing across distributed databases in parallel. To create a custom aggregation function, use MarkLogic's C++ API to create and compile them into a shared library. After installing the shared library, call the shared function as a user-defined function during search. Custom aggregate functions are best used for analyses that produce a small number of results rather than analyses that produce results in proportion to the number of range index values or the number of documents processed. Perhaps we might want to do an analysis over our book documents, finding what days of the week they are published. This might lead to an interesting insight that might point out we have more new books on Tuesdays rather than on Fridays. This is example code of a theoretical user-defined function that calculates the days of the week for a set of given date published values. A function called days of week would need to be created with MarkLogic's user-defined C++ API, then compiled to a shared library and installed. On the first line, we include the JSearch library. This example retrieves values from a JSON property of publish date, representing the date the book was published. Next, we call the jsearch.aggregate method and use the jsearch method of .udf to call the user-defined function. Here we're calling a user-defined function called days of week from a shared library called sample plugin, installed to a directory called native. Call the jsearch.result method to execute the search and return the results from the user-defined function. Note, you cannot use the JSearch API if your user-defined functions require additional parameters, but other MarkLogic functions exist to do so. In this tutorial, you learned how to return values and tuples using the .values and .tuples top-level methods in JSearch, about the .aggregate method in JSearch, about built-in aggregation functions available, calling a user-defined function for custom aggregation. Code examples can be found at MarkLogic University's GitHub repository at github.com/MarkLogicUniversity/JSearch. Thank you for attending this on-demand tutorial. For more tutorials, please visit mlu.marklogic.com/ondemand.